In this chapter, we will be studying quadratic functions. In this lesson, we will be converting a quadratic written in standard form into vertex form by completing the square.
All right, well, hi everybody. Now we're going to talk about something called completing the square. What this is going to allow us to do is going to take the equation of a parabola that is in standard form, okay, which is your ax plus ix squared plus bx plus c, and we're going to convert that, yoink, over here into vertex form. And the reason why we want to do that is because in vertex form you can see the vertex, you can identify the axis of symmetry, the maximum minimum values so easily, okay? But when it's in standard form, a lot of that information isn't quite as clear. So that's one of the reasons why we might want to do that. And so we're going to take a look at a procedure for converting from one to the other here. All right, now, so to get a sense of how we're going to do this, let's just take a look at perfect square trinomials. I'm going to zoom in a little bit here. Always do that, always go backwards. Here we go. So a perfect square trinomial, because when you get two binomial perfect square trinomial, I said that wrong, have two different, have two factors, yikes, that are the same. So for example, x squared plus 8x plus 16, the two factors are x plus 4, or x plus 4 squared. And the only other really version of this that we need to consider here is x squared minus 10x plus 25. Now just notice the difference here. Okay, now granted the numbers are different, but really what's important here is the difference, the subtraction here as opposed to the addition. What that does is that just changes the signs. So when I distribute this through, I'll get negative 5x, there's my negative 10. And then negative 5 times negative 5 is the positive 25, so we get this x minus 5 squared. Okay, now if you can answer the next question or two here, then you're really going to get a good sense of what completing the square is all about. So what we want to do here in this next question here is we're going to add a constant so that the following expression is a perfect square trinomial. So x squared plus 18x plus what would make this a perfect square trinomial, something that looks like this. Now I know it's going to be addition here because it's addition right here. Now let's just think about that. Now let's think about how we got the 8 here. The reason why we got the 8 here is because when you distribute this out here, okay, you get x squared, yeah, then it's going to be 4x plus 4x and then plus the 16. That middle term shows up twice. So when you put those together, it's 2 times 4x. And there's where my 8 is coming from. So when I come down here, I know that this is going to be 2 times what? Well, I know that's going to be 2 times 9x. So that means that this must have been 9 right there, right? Now, having done that, what number would have to go here? Well, it would be 9 times 9, or 81. So what's key here is taking out the 2 that we already know has got to be in that middle term. Come over here, x squared minus 4x plus something makes this a perfect square trinomial. Now again, I know this is going to end up being x minus because it's going to take the same sign as that. And I know right here there's a 2 in there. Well, if you take a 2 out of the 4, you're going to be left with 2x. So I know that this must have been a 2 there. X minus 2. Now, and if that's a minus 2 right there, when you square that negative 2, you're going to get positive 4. So even with just those 2 terms up front there, okay, I can complete that perfect square trinomial. And hopefully you're now starting to get a sense of why we call it completing the square. Okay, so what we do is we take that middle term. Here's this little summary here. We're going to take that middle term here, divide it by 2, and then we're going to square that. Okay, now if you want, the other way of thinking about it here is if you do this in general here, if you got this x squared plus bx plus c, okay, then if you want to get if you have those first 2 terms, now, and by the way, in order to complete the square, you have to have the quadratic term and the linear term, okay, the x squared and then the x there. To get that c value, we simply take b over 2 and we square it. And there's your little formula for figuring that out. But it basically boils down to this. You take that middle term, that linear term, the coefficient there, divide by 2 and then square it. Okay, so now here are some steps for completing the square. And really, I mean, these are your steps here, and I can explain this to you, but really until you see an example of it, this really is just a lot of mathematical blah, blah, blah. You actually need to see it happen before you really get a sense of what's going on. I am also going to add a 0th step here, okay, which is in my 0th step here, and I know this is a little different, a little odd for me to write this, and it's going to look weird, but I'm going to move the constant over. There's my 0th step. And I'll explain why I say that in just a little bit here, and hopefully you'll get a sense of and appreciate why that might actually be an important step. But then what you're going to do is, if the coefficient in front of the x squared is 1, then you simply move on here. But if it's not 1, you have to factor out that coefficient from the first two terms. And remember, I only need the first two terms. Okay? And if you've done this first step over here, you're only looking at those first two terms anyway. You want to move the constant out of the way. Then you complete the square. You're going to take that middle term, divide by 2, square it, and then you're going to add that constant. Now there's two different ways that you can do this. Okay, I'm going to choose one particular method, kind of stick with it here, but just bear in mind that if you're in class and you hear your teacher doing this a slightly different way here, yeah, that's fine. There are 2 different ways you can do this. Okay, but we're going to take that middle term, divide by 2, square it, and then I'm going to add and subtract it right away. I'm going to add it and I'm going to subtract it right away. And again, I'll talk about why when we start to do an example here in a second. And then what we'll do is we're going to factor what we've set up there to identify the perfect square trinomial. Okay. Anyway, let's just do an example here. This is a lot of blah 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 until we actually go through one. So here we go. X squared plus 10x plus 14. Now what I would recommend being your first step is to do this x squared plus 10x, to actually put some physical space in there, move that plus 14 over. And I know that might seem a little bit weird, but believe me, it makes a huge difference to get that constant out of the way. It's not necessary for the completing of the square process here. Then I take a look at those 2 terms here. Now because the coefficient in front of the x squared is 1, I can do what I was just doing a little while ago. Okay, so this is the 10 here, so I know that's 2 times 5x. It's the 5 that I need here. And in fact, even from here, I can tell you right down here that that's going to end up being x plus 5 squared. I already know that, okay, because I grabbed the 5 out of that. But I still need to walk through these steps here. I can't just go down to this step right here and just say, that's a 5, and jump down to here, because there's a second part to this problem. So what I'm going to do here is, I know that there's that second value is going to be 5, and when I square that, I'm going to get 25. And remember, I'm squaring it because what I'm looking for is a perfect square trinomial. So the pieces there are all multiplied together, and that 5 would have been squared there. But then I do something that maybe for some of you is a little bit counterintuitive. I'm going to subtract the 25. 25 minus 25. Now the reason I do that is because I can't actually do anything to change the equation. Okay? If I was just to add 25 to this expression here, I have significantly changed the equation. But if I add 25 and then immediately subtract 25, well, what have I done? Well, I've added a 0. I've done nothing. So this gives an overall result of no change to it. But it does let me kind of restructure this a little bit. Because now what I'm going to do is I'm going to move that 25 over. I'm going to associate it with the 14, with the constant, because now that constant comes in. I already know that this piece right here is going to factor down to x plus 5 squared. I knew that right away here. What I didn't know what was going to happen outside here when I threw in that number to balance the 25. So negative 25 plus 14 gets me negative 11. There we go. This is now the expression here in vertex form. And I know that my vertex is going to be negative 5, comma, negative 11. Okay? I hope that makes sense. Okay? If you're still a little bit foggy on it, then believe me when I say what you really want to do here is just pay attention to how I do this over the next few questions here. Just watch the procedure happen again and again and again. And let that kind of sit with you. It really may be the case here that what you need to get comfortable with is the procedure, and then I think your understanding of what's going on will follow. Which seems a little bit weird. Sometimes you think, well, no, I got to understand what's going on first before I can understand how the procedure works. And no, really, in some cases here, particularly in mathematics, understanding the procedure actually comes before understanding why the thing happens. So trust me on that one. So let's keep working here. Let's take a look at another one. Let's say that the coefficient in front of the x squared term is something other than 1. Okay, so we're going to complete the square on this guy right here. 2x squared minus 12x plus 13. Again, the first step that I would introduce here would be to go y equals 2x squared minus 12x, and I'm going to push that positive 13 over. I'm going to throw in some separation so that I don't do anything with it, because I don't do anything with it. Not for a little while yet. Now, between x squared and negative 12x, there is a common factor of 2. Don't take out the common x. Okay, please don't misunderstand what I'm trying to accomplish here. I need to complete the square. I need the quadratic term. I need the linear term, just like back here. Okay, I needed the quadratic term. I needed the linear term. Okay, if you take out the common x, you've ruined that. Okay, we're not using that anymore. So take out the 2 though. I do want the coefficient to be 1. So when I take out the 2, it's 2 times x squared minus 6x. Okay, now actually there's a missing set of brackets here. There should be another set of brackets here. So now what we're going to do is we're going to take a look at that middle term here. I know that there's a 2 in there. Okay? I know that there's a 2, and if I take the 2 out of the 6x, I'm left with a 3x. And so there we go. So I already know, even at this point right here, I can already tell you, going down to here, I already know that that's going to be 2 times bracket x minus 3. I got that, because I grabbed the 3 out of there. Okay? What I don't know is what the constant is at the end. So this is what I do here. Okay? Take a look at that 3. I am going to square that 3. So I'm going to add the 9 and I'm going to subtract the 9. Now, again, I had to put brackets here because this is all still within the brackets. Bear in mind that everything that I've done here was multiplied by 2. I factored the 2 out. That gave me a set of parentheses here. Everything that I'm doing is within the parentheses. Now, in order to complete the square, I only need those 3 terms. I don't need the negative term. I only need those 3 terms to factor it. The x squared, the linear, and then the positive square. I don't need that one, so I'm actually going to get rid of it. But to get it out of these parentheses, yeah, I got to multiply by that 2. So that's what's happening here in this step here. We're going to take that 2, multiply it by that negative 9, and so when it pops out of the parentheses there, I get negative 18. Which is great. So now this is going to factor down to this x minus 3. I knew that. I knew that way up here. Okay? But what I didn't know was what number I was going to take out there. And now I put together the negative 18 plus the 13, I get negative 5. And there it is. There's my answer in vertex form. And I can identify that the vertex is the point 3, comma, negative 5. Good. I hope that makes sense. Okay, now let's take a look at some examples here, okay? And I'm hoping that after we do a handful of examples here, you're going to get comfortable enough with the procedure here that not only will you understand the procedure, but you'll have a better understanding of why we're doing the things that we're doing as we go through this. So let's take a look at this first one here. And my first step is going to be to move that constant term out of the way, because I don't need it. Not to complete the square. To complete the square, I only need the first 2 terms of that perfect square trinomial. And what I'm going to do is I'm going to find the third one to finish that off, and then then I can factor it down. Okay, so that's really what I'm trying to do here. I take the first 2 terms. This is the wrong end, so I move it out of the way. I'm going to create the correct ending for a perfect square trinomial, and then I'll fix everything else around that once I've dealt with that. Now, the coefficient in front of the x squared is 1, so I don't have to worry about that. Okay, I can jump right to breaking apart this middle term here. Now I know that there should be a factor of 2 in there, and when you take the 2 out, okay, because bear in mind when you square, okay, a binomial, that middle term is always going to have a factor of 2 in it. Okay, so I take that 2 out, I'm left with a 3. Now that tells me 2 steps down, okay, 2 steps down in my problem, I already know that this is going to end up being x plus, because of that sign right there, plus 3. I know that the binomial will factor down to this. Already well aware of that. What I don't know is what comes out at the end here. But that's what I'm going to spend most of my time trying to figure out here. So I know that what I've got to add here, it's got to be the square of this. I'm going to add the 9. Okay, so there's my x plus 3 squared. X squared plus 9, 6x plus 9. But I can't just add 9 to this. I got to balance it out like that. Okay, so I've added a 9, I subtract a 9, so that my overall change to the equation is actually nothing. I haven't done anything. I'm changing the way it looks, but I'm not changing any of the values here. Now, what I need to do is take that negative 9 out of the parentheses here, because I only need those first 3 terms to create this x plus 3 squared. So I'm going to take the negative 9 out. And you do that by multiplying it by the coefficient of the parentheses here, but it's just 1 in this case. So that's convenient. So it's just going to become negative 9 when I take it out. And then negative 9 plus 5 is going to be negative 4. So there we go. That's the expression here in vertex form. And I might just quickly identify the vertex here. It's going to be negative 3 comma negative 4. Okay, good. Now let's take a look at another one. A little different here because I can see that there's a leading coefficient, but again, the first thing I'm going to do is move that 3 out of the way. I don't need it. I don't want it for the time being. I'll get to it later. Then I've got these 2 terms here, the quadratic and the linear terms here, but there's a coefficient in front of the x squared, and I don't want that there. Now I'm not going to take out an x because I need it to stay as a quadratic and a linear term, but I will take out the 2. That leaves me with x squared plus 10x. And then I got that plus 3 out there. Now I can take a look at this pattern here and figure out what that last term is going to be. I know that in front of the linear term here there should be a 2. That's going to leave me with a 5x. Okay. So I know already, 2 steps down, I already know that this is going to end up being 2 times x plus 5, and that'll be squared. I already know what the binomial is going to look like. What I don't know is what's going to happen out here. So now that 5, when you square it, you get 25. But again, because I can't just randomly add a value to my expression here, I got to subtract it so that the overall result here is 0. I haven't done anything. But I don't need those 4 terms. I only need the 3 terms to factor down to get that x plus 5. So I got to get rid of the negative 1 here. And I do that by multiplying by that coefficient out front. That's how you get it out of the parentheses. Now 2 times negative 25 is going to be negative 50. Now, negative 50 plus 3 is going to be negative 47. So my vertex here is the point negative 5 comma negative 47. Whoops, can't see that. All right, let's take a look at another one. Okay, so y equals 4x squared minus 28x minus 23. So again, the very first thing I'm going to do is move that constant term out of the way. Don't need it. Okay, don't need it to complete the square. I only need the first 2. But I notice there's a coefficient in front here, and I don't want that either. So I'm just going to take the coefficient out. I'm not going to take out an x. And I keep saying that because it's so important that you don't do that. But I'm going to take out the 4. Whoops. It's going to leave me with x squared minus 7x. Close the parentheses with a minus 23 here. Awesome. Now I've got the beginnings of that pattern that I can work with here. However, I do run into a little bit of a problem here, and you're not going to be overly thrilled with this, but it's just a pattern that I've established here. I'm just going to keep walking through it, and I hope you understand that even though it's going to get a little ugly here, it's not actually going to get all that hard. I know that there's supposed to be a 2 in that middle term. I know that. When I expand a binomial squared, the middle term has always got a factor of 2 in it. However, 7 is not an even number. I can't factor a 2 out of that evenly. So what that's going to leave me here with is 7 over 2. Now, before you jump in and say, oh, I hate fractions, I'm going to use decimals, I'm going to write that as 3.5. Let me just caution you here. I think you'd be smarter to put 7 over 2 here. Okay, in fact, I don't even just think that, I know that. I know that you'd be smarter to leave that as 7 over 2. Now, what this means for me is 2 steps down, there's my coefficient out front. I already know that this binomial is going to become x minus, and I know it's going to be 7 over 2. I know that. So x minus 7 over 2 squared. What I'm interested in is what I'm going to get out here. This is the part that I don't know yet. And I do that by walking through the steps of evaluating it here. Now, let me ask you something. I know that what I'm supposed to put here is this 7 over 2 squared. Now, is it easier to square 3.5 or is it easier to square 7 over 2? Now, if you've pulled out your calculator, you're probably going to say, well, it's easier to square 3.5. But I don't need my calculator here. I know that 7 squared is 49 and 2 squared is 4. And I think it's much quicker to work with it like this than it would be otherwise. Now watch what happens here. My next step, because I only need those 3 terms here to get down to here, okay, I just need those first 3 terms to represent this x minus 7 over 2 squared. And if at this point here you're getting lost saying, well, how do those 3 terms become this? Okay, bear in mind that that's how we started this here. X squared plus 8x plus 16 is just x plus 4 squared. If you apply that square to this whole thing, it becomes this trinomial. That's what we're doing. But I know that after a while, sometimes it's easy to get lost in what's going on here. So I got to get that negative 49 over 4 out. And I do that, okay, to get the negative 49 over 4 out, I do that by multiplying by that leading coefficient, which in this case is 4. So 4 times negative 49 over 4 is simply going to be negative 49. Okay, that 4 will cancel with the 4 in the denominator. And so now I just got to put those two together. And negative 49 minus 23 is going to be negative. I just got to make sure I do this because I'd be embarrassed if I got that wrong. I believe it's going to be negative 72. Okay? And so there we go. And our vertex here is going to be the point positive 7 over 2 comma negative 72. Okay, I know that working with fractions is not everybody's cup of tea, and sometimes we try really hard to avoid those. But I think you'd be better off, in this case, just to kind of embrace the horror and just deal with it, because I think, honestly, it's going to cause you a little bit less stress in the end here. The numbers you're going to work with are actually going to look a little cleaner. All right, let's work with another one here. It's got a slightly different issue. Notice there's a negative in front. Okay, that negative in front we already know is going to cause a lot of students a lot of problems. Okay? It's something that you're just going to have to deal with. You're also going to have to be prepared for it. Okay? Understand that it is coming on an assessment, that negative in front. So it doesn't really change my approach at all, though. Okay? I'm still going to move the negative 2 over because I don't need it. My leading coefficient here is something other than 1. It's negative 1. So I got to deal with that first. But this is what they assume a lot of people are going to do wrong. And it's true. I wish that was just, you know, the people in charge of the curriculum being pessimistic. But the truth is a lot of people get this wrong here. When you factor that negative out, it causes these two terms to change signs. Now, I'm not taking it out of the negative 2. That negative 2 sits out there. It's all by itself. It's happy. It's not bothering anybody. It's cool. It's good. Okay? It's just out of those two terms right there. But it's going to change the signs on both of those. By the way, where the mistake gets made is people will forget to take it out of that second term. And that is, by the way, like a hugely common mistake. So be aware that that is an issue. Now we take a look at that middle term. We know there's supposed to be a 2 there, which leaves us with a 5. So I know that already, 2 steps down, I already know what that binomial is going to look like. First of all, I know there's going to be a negative in front. I know this is going to be x minus the 5 squared. And again, what I don't know is what that constant is at the end here. So I go back. I see that I kind of have a 5 there. When I square that, I get 25. There we go. There's my perfect square trinomial. But you can't just add the 25. You've got to subtract the 25. So that my change is 0. Now I'm going to get that negative 1 out because I don't need it. I don't need it to create that trinomial. But I take it out by multiplying by the negative in front here. And that changes that to positive 25. And then positive 25 minus 2 is going to be 23. And so our vertex here will be the point 5 comma 23. Okay? So I hope that makes sense here. Between these two right here, the one with the fraction and the one with the negative here, okay, we're gonna lose a lot of people. It's gonna cause a lot of stress here, but honestly it's because people get kind of fixated on their issues with fractions, and it kind of stalls them out. Just keep going, just keep working through this. Okay, let's try another one here. So first step, move the 2 out of the way. Second step would be to divide out the leading coefficient if there was one, something other than 1, and there isn't. So I'm not going to worry about that. I'm going to jump right to pulling the 2 out of that linear term. We're back to this fraction problem because the coefficient of the linear term isn't an even number. So I'm going to get this fraction, but it's only going to be over 2. So I already know, as soon as I've established that, I already know 2 steps down that this is going to end up being x minus 5 over 2 squared. Already know what the binomial looks like, which is great. What I don't know is what's that constant out at the back there. So I'm going to take that 5 over 2 and square it. But just square the numerator, square the denominator. Square the numerator, square the denominator, and subtract it. So there we go. Now I've got these 4 terms, but I only need the 3. So I'm going to move that one out. So I get x squared minus 5x plus 25 over 4. And then I'm going to take the negative 1 out here. And because there's no leading coefficient other than the 1, it's not going to change at all. It's just going to be negative 25 over 4 plus 2. Now, herein lies the issue. This is the part that you've been kind of, if you don't like fractions up to this point here, whether you like fractions or not, it really hasn't done anything. Now all of a sudden I got to worry about adding fractions together. So I'm going to need a common denominator. So I'm going to add the 2. I'm going to need that to be have a denominator of 4, which means it's got to be 8. So negative 25 over 4 plus 8 over 4, that's going to end up being negative 17 over 4. And so now I can write that my vertex is this point, 5 halves common negative 17 over 4. All right, let's do another one here. One more. What's the first thing I do? Well, every step along the way, the first thing I did was to move out that constant. Every time I did this, the second step was to take out the leading coefficient. Now in this case, it's a negative 2. And in this case right here, notice that that is going to make my linear term here a fraction already. Okay, even before I get to the point of trying to finish up the square here, I've already got a fraction here. So, okay, so this one's a little bit more involved. I know that there's still got to be a 2 in here. Now, don't get thrown off and say, well, if it's already in that factored form. Yeah, but that's not because of anything I've done to complete the square. That was there already. I've now got to take out another factor of 2 here. And I've noticed that this throws people off here, but this is going to end up being 5 over 4. Bear in mind that dividing by 2, okay, dividing a number by 2 here is like putting a 2 in the denominator. So if there's a 2 there already, so just think about it like this. In order to factor this 2 out, I took that 5, I had to divide by 2. So what did I do? I put a 2 in the denominator. Now I have to do this again, okay, because of the completing the square procedure here. I have to take out another 2. But that again involves putting a 2 in the denominator. Now there's already 1 down there, so when I do this I get a 4 down there. Now this means, for me, 2 steps down, I already know the value up front is going to be negative 2. I know that this is going to be x minus 5 over 4 squared. What I don't know is the number out front here. Now notice how, in spite of the fact that the number has changed, I'm dealing with fractions here, and I know that requires us to think a little bit more carefully about it. What I'm doing hasn't changed. I took out that leading coefficient, I've taken a 2 out of this, I built my binomial here. Now what am I going to do? I'm going to square this number and add it and subtract it. So 5 over 4 squared is 25 over 16, and then I'm going to subtract it, minus 25 over 16. Okay, that hasn't changed any. Like there's nothing has altered in terms of my approach. Now I'm going to take that negative term and pull it out. So negative 2 times x squared minus 5 over 2x plus 25 over 16. To get that out, I have to multiply it by that leading coefficient there out front. And it's just going to be negative 2 times negative 25 over 16. Now, you might have to think a little bit about this, but the fact is, you're doing it exactly the same as you've done it before here. So that's going to end up becoming positive, and I'll do it this way, 50 over 16, because I know there's going to be a lot of people that aren't going to be comfortable with simplifying that too quickly here. So negative 2 times that negative 25, and then 1 over 16, if you want to think of it like that, with a minus 1 out back here. Now, 50 over 16, okay, 50 over 16, that is going to be the same as 25 over 8 minus 1. And 1 is going to be the same as 8 over 8. 25 minus 8 is going to be positive 17 over 8. And there's that value that I was looking for, so my vertex is the point 5 over 4, comma, 17 over 8. So I really hope that this last example kind of illustrates the fact that the procedure is the same, although the work that you do with the individual values here, that might get a little bit more complicated because of the fractions here, but you're still doing the exact same thing. Okay, dividing by 2, squaring it, taking out the negative, grouping together those values at the end here. That's all we're doing with completing the square.